Okay. Yeah, once again, good evening everyone. Myself Manoj Kumar Dondurala, Best Day Ambassador 2021. I thank each and every person for being here with us today. I would like to give my heartfelt welcome to our honorable speaker and all the participants over here. I consider it as my utmost pleasure to invite you all for today's wonderful event, Electrical Vehicle Plug in the Revolution, organized by IEEE Vaagdevi College of Engineering Student Branch in collaboration with IEEE Vaagdevi Engineering College Student Branch. I take immense pleasure in inviting Mr. Venkata Sarath Panatula, who is co-founder and CTO of Enflare Technologies. He also trained more than 3,000 students and delivered 70 plus workshops on national and international level. Now I request Mr. Venkata Sarath sir to take over the session.
Thank you, Mr. Manoj. Thank you, Nagraj. Thanks for making me a part of this outstanding session. So, without taking much time, so good evening to honorable the faculty, students, and the management of Vaagdevi College of Engineering. And I have noticed many of the participants in different parts of our country also. I'm happy to see, and it's my pleasure to interact with you all. So, very good evening once again. So, let me share my screen. So please confirm, Manoj, please confirm whether this presentation is visible to the participants or not.
Yeah, okay sir.
Is it visible?
Yes sir, it's visible.
Okay. So what about the participants? Can you able to see the presentation? Please confirm the chat box, yes or no. This is for just for confirmation. Okay. Thank you, Sairam and Naveen and Krishna. Thank you very much. So welcome you all for the webinar on electric vehicle. So where it's nothing but revolution in the coming days. So before going ahead with the actual topic, so let me take 2 minutes of your time to walk you through what I am and who we are actually. So myself is Venkat Sharath, like Manoj introduced. So I'm a co-founder and CTO of Inflight Technologies, and I have delivered more training sessions on different topics like electrical design and industrial automation, PLC SCADA, and MATLAB applications of MATLAB in electrical engineering, and robotics and IoT also. And this is the agenda for our training session. So at the beginning, I would like to walk you through what is an Inflight Technologies and who we are exactly. And we'll start with the basic level about what is an electric vehicle. Many people have a basic understanding about what is electric vehicle. So let me take a few minutes of your time. And what is the exact definition for an electric vehicle that I'm going to introduce you. Next, we can see what are the main key parts. And as we are the electrical engineers, or might be different disciplines, they have to be familiarized with what are the key parts of electric vehicle. Next, what's the power flow inside of it, and what are the why we are switching over to electric vehicle. That means what are the basic benefits we are having, and what are the challenges that are facing in the energy electric vehicle sector, and and there are some key points that we can need to discuss. That is also we can discuss, and there are some state and government policies many people are not aware about the electric vehicle mobility. That also we can discuss. In the final, the job prospects. So, what are the main opportunities for the engineers like you and me and the students? What are the if you want to pursue a career in electric vehicle or mobility? So, what are the job prospects are there? So, at the final, there should be conclusions. So, who we are actually, that means Info Technologies. We are actually training provider for tech enthusiasts, working professionals, and who want to excel their knowledge in the best industrial practices which is happening all over the world. And we are acting like a bridge between industrial experts and the who is going to learn the technical topics. So many of the people have couldn't able a better access about what's happening in the industry or industrial practices. So we are going to bring the industrial experts to a particular location or industry or, or to your institution to make you understand about the industrial tools and practices and how we are actually delivering this training providing. So by organizing customized trainings like workshops, internships, and industrial training based on the client's requirement. So we have been into school workshops also. Some schools, international schools, are expecting like Python programming and C language and robotics also. And we strongly believe that apart from this, the technical knowledge, intrapersonal skills also definitely necessary if you want to sustain in this present fast pacing. And we have been in research projects also. If you bring up a new kind of technical idea, we can make it into reality. We can make your idea into the reality. So these are the trending workshops which is organized with Play Technologies. We are specialized in IoT, and recently we have been associated with NSIC and Government of India Enterprise, and we have delivered IIoT also, hybrid electric vehicles and PCB design. And recently we have introduced Industry 4.4. So these are the school workshops, and these are the specific domains we pick up to do the research guidance and research projects also. And how we can differentiate from the other training institutes. There are different training institutes. So we always choose like an hands-on training sessions. So out of 100%, so 90% should be practical and only 10% should be theoretical we can create. So we never compromise on delivering the quality training to all the participants. That is the main motto of Inpay Technologies. The trainers or industrial experts we are bringing are well experienced in delivering the training sessions in best reputed institutions like IITs, NITs, and in countries like Gulf countries and in the Malaysia and Indonesia also. So our vision is we would like to see a best leading training provided in next coming 2025, the best leading training provided in our country, and where we need to maintain all the global standards. So these are our clients. So this is how which is listed over here, and this is some of the work we have done. So let's understand about the electric vehicle. So many people have different kinds of knowledge or understanding about the electric vehicle. So let me put in front of you what exactly the definition we can name it as. So electric vehicle is a vehicle which is propelled by an electric drivetrain, which is going to take the power from the rechargeable batteries. And this is going to charge the batteries when the different sources like solar panels, fuel cells, and might be the electricity grid. We can charge these batteries, and which is used for the normal public loads. So it's normally a vehicle which is going to propel, which is going to drive by using of an electric drivetrain. So this is what an electric vehicle is going to be differentiated from a conventional drivetrains. So normally we can call it ICE, internal combustion engines we can name it as, which is going to run through fossil fuels. So while coming to the electric drivetrain, it is going to be run through the battery. Okay. So suppose if it is a drivetrain, it's going to be drive the vehicle by using the battery. We can call it as electric drivetrain. And if you take a conventional one, internal combustion engine, which is drive to the fossil, that can be named as normal power drivetrain. We can name it as. So now I would like to ask a question. Let's make it as an interactive session. So you know about voice is not audible. Manoj, please confirm. It's not audible to all.
So you are audible,
Hello.
sir.
Okay. So one of the participants have put a message in the chat box. That's why I'm asking. Okay. There's a question for the participants. Let's make it as interactive. So why we need to move it on to the electric vehicles? So we already having conventional vehicles. So why we move it on to the electric vehicles? So in general, what you know, just put it out. What do you think? Why we need to move it on to the electric vehicles? Just
Can we
type it in the chat.
unmute ourselves, or we have to type it on the chat menu?
If you type it, it should be better, I believe.
Okay.
Okay. So environmental protection purpose, good, Aditya, and to reduce pollution, good. High cost fuel, that is also important. Point Navin, good. So lack of fossil fuels, natural, good. Okay, great, great. I'm happy to see the response. I truly appreciate your responses. Yeah, like Mr. Prasad have put that reduce maintenance. It's a good point also. Very good. Thank you. So these are the major concerns that we can consider why we are moving on to the electric vehicles. So in earlier days, it might be in 18th century itself, we are having electric vehicles. Not in the 21st century, we bring up the electric vehicles. So they have started with electric vehicles, and in parallelly, they are gradually increasing of using of the fossil uh, vehicles also, which is nothing but internal combustion engine chambers. So what's happening in between? So in 19th century, so they come up with two constraints where they're going to stop using the electric vehicles. They are encouraging the fossil fuels only. So one is called the charging. Charging is the major concern that we have to consider because so yes, any issue? I think one of the mic has been unmuted. Okay. So one is the major concern, like the charging is the major issue. So suppose if you charge at your home, so it can drive up to some more kilometers. Suppose if you take at the earlier test in 18th century, according to my study, so I have done my research. So where they have been given some specifications like what at one time charge, it may go up to 20 to 30 miles. So after that, in a remote location, if the vehicle has been stopped, it is very difficult to charge the vehicle and go on. And the charging time also very big constraint because it may take almost 24 hours of time duration. Now it has been changed. So at the earliest stage, it's almost 1 day of time duration to charge the vehicle. So that is the major concern. While coming to IC engines, so it is an very 2 minutes to fill the gasoline or the vehicle in the car to drive the vehicle in 2 minutes, and then we can go ahead. So and while coming to this, it may drive up to 40 to 50 miles, and it is easy for us to access also. This is the major concern which is here and which is going to cover shorter distances. So that's why in earlier days, the people has put this electric vehicle aside and started using about the fossil fuels. So now, because of a lot of improvements and advancements like power electronic components, and by using some latest technologies like electronic control units, so there they can bring up the electric vehicles. So now let me make you understanding about what are the key components in an electric vehicle. Suppose this is the internal a view of the electric vehicle. So this is the chassis. On the chassis, what are the all the components should be mounted. So let me show you what are the components instead of it. So during this session, if you have any questions, just put it on the chat box. So once it is done, I'll take up your queries also. So let's make it as more interactive. So this is where the traction batteries should be located on the chassis, which is at the center of the vehicle. So this is one kind of advantage where it's going to distribute the weight onto here, where it can give more stability for the vehicle. While you're driving the vehicle, it can give more stability. So this is the batteries where we are going to charge and which can help us to propel the motor. Okay, which can drives the motor, gives the energy to drive the motor. So this is the place where we are going to charge. This is acting as an input from the grid or the charging station to the vehicle. So there is an another battery, we can call it as an auxiliary battery. So this battery will be helpful to give the supply to the auxiliary accessories, which is nothing but suppose if you take headlights or if you take an audio head unit, we can call it as AHU. And if you take mobile charger, so for this small kind of applications, we can use these auxiliary batteries. Normally, these auxiliary batteries in between 12 volts to 48 volts. So at this present situation, we are moving to 12 volts. In coming days, we can expect 48 volts. So this is called onboard charger, which is acting like an the inverter, we can name it as. So after getting the inlet of the power supply, where it's going to convert AC supply to DC supply, and that DC is given to the traction batteries where it's going to charge, and some part is given to the auxiliary batteries to charge. So two batteries is going to charge. One is traction battery, another one is auxiliary battery. So this is the battery converter. We can call it as DC to DC converter also. Okay. So where it can help us to drive the motor, and for the charging of auxiliary battery, we can use this DC to DC converters. So when we discuss about the power flow, there I'm going to explain. So this constraint. Okay. So let's go ahead with the next one. So this is the electric motor, uh, where it is located on the power train. This is called electric drive train. Okay, where we are going to mount this motor here. So basically, we might be use induction motors and permanent magnet synchronous motors and brushed DC motors we can use. Okay, so most popularly, the permanent magnet synchronous motors popularly used. So next, this is called transmission. So this means the motor is converting the electrical energy to mechanical energy. This mechanical energy has been sent it on to the transmission. So there we are having a gearing mechanism where it's going to drive the wheels. This is called the transmission wheels. So it is having the gearing mechanism where you can drive the wheels. So this is the motor drive where it's going to control the frequency. The frequency to this. Suppose the inlet for this motor is nothing but the AC supply. So where it's totally depending on the frequency. So where by using this motor drive, it's going to control the speed of the motor. Okay, there we are going to use this motor drives. So inside of it also we can observe some the power electronic components or semiconductor devices where the switching should be happened in a proper way, where it's going to control the speed. So these are the major key components here. So let's take one component at a time and let's discuss like a brief overview for the few minutes. So then I can go on to the why it is required to move on to the electric vehicles we can discuss. So many people have the basic understanding. So this give you a clear picture about the infrastructure. So as we are the engineers, we have to understand what is the technical components which is happening. So this is the basic the block diagram of the key, so that you can clearly understand instead of looking at this. So you may not follow up clearly. So that's why I bring up this. So this is the component. Let's see one by one. So this is where we are having to plug in the vehicle, where it's acting as an inlet when the power grid to charge the batteries. So after getting the plug-in, it enters into the onboard charger. So where it's going to convert the AC to the DC. So which is acting as an the rectifier circuit also, we can name it as. Okay. So AC to DC. So sometimes we are having instead of AC grids, we might be using some DC chargers itself. So there the scenario is different. So here I'm considering the actual grid, three-phase AC grid. In that point of view, I'm explaining. So where it's converted to AC to DC, and this is given to the power converter. So where we are going to have DC to DC, we are having. Okay. So like I explained, this is called onboard charger. So after reaching to the onboard charger, the output DC is given to the traction bank. Okay, where it's going to charge the batteries. And nominally here they haven't mentioned clearly. This is called there is one more component which is called it as a battery management system. Okay, which they haven't mentioned here. So instead of confusing you all, I just take out that component, but you just keep it in your mind. So there is a battery management system. So there are two kinds of modes should be there. One is the driving mode and regenerative mode. So there the battery management is playing a very important role. Okay. So sometimes the the PMSM started acting like two kinds of things. One is called motor and generating motion. So there, the charging or discharging should be happen at these both conditions. So there we have to take care about battery management system. So this is a very big challenge for the engineers also. So typically, what is the capacity? It should be 10 and 100 kilowatt hour battery capacity we can consider. So at the end, I have shown you some case studies I have gathered from different sources to make you understand about what is the present scenario about the battery capacity that might be using. So if you talk about the types of batteries, so three major types. One is the lead acid, a nickel, and lithium ion based. So lithium ion polymer. So the first one is the lead acid, but due to some constraints, it is not popularly used. So because of we can call it as low density, and which is sensitive for temperature. Okay, if the temperature has been gradually increased, the short circuiting of the batteries might be happen for the lead acid. So that's why, due to some limitations, they were moving on to the nickel based. This is the, we can call it a second popular nickel based we have been used. So there's the first popular is nothing but lithium based. Okay, so you may ask you a question, why you just represent the lithium based? Why should it be the nickel based? Already lead acid, I have already explained, low density sensitive to temperature. So for the production purpose, we move to these two options. Suppose, let me take an example, like suppose 20 kilowatt hour of the capacity. Let us take. Okay, so let me tell you about the major differences. So let us consider this as the weight. Okay, so for the lead, so 20 kilowatt hour battery can take, it weighs around 500 kg. While coming to the nickel based, it may around 300 kg. And while coming to the lithium ion, I am going to consider this one, lithium ion I'm considering, which is around 180 kg. So now you can compare weight point of view with the same capacity. So lithium ion is the weight less. The weight is very less, but the capacity it is having here. That's why it is having maintaining a good density with less weight. Okay, so that's why in Tesla, yes, and in the coming days, it's coming to our country as a Tesla Model 3 also. Okay, so this is an autonomous car, right? So there they are using lithium batteries, almost 800 to 900 battery cells are there. Okay, so there they are going to use lithium ion batteries because it's a weightless, and which is having the good density. Okay, so for your sake of understanding, I have given you some case study. So are you following, everyone? I'm having a doubt actually. So am I moving too fast? Just let me know. Are you following? Is everything all right?
Yes, sir.
Okay, okay. Thank you, Mr. Thank you. Thanks, everyone. Yeah. So, so next is the battery converter. So this is called DC to DC converter. So based on the requirement, it's going to step up and step down. Should be happen. Okay. Why I'm asking about step up? So when you are driving the motor, we can make it a step up. Okay. When we can do the step down, so there is a battery name called auxiliary battery. Okay, so this battery is going to give the energy for the auxiliary accessories like audio head units. Suppose if we want to play the music, this is called audio head unit, we can name in automotive terminology. So there are some other that means anti-locking system. Okay, so like this kind of small accessories, so we can step down to the 12 volts or 48 volts. It depends on the requirement. Okay, so there we are going to use this converter. This is playing a very important role because this is the main source where it's going to supply for the propulsion of the electric drive. So, so what we are talking is a motor drive. Like I already explained, it is having some power electronic or semiconductor devices based on the configuration we might be having. So where it's going to control the speed, one is constraint, and next is torque, and the other one is rotation direction. Suppose if it is rotation in the motor, that means in the driving mode, it's okay. Suppose if it is generation mode, the direction should be different. Okay. So let me tell you the two cases while talking about motor drive. Sometimes it might be acting as driving mode. Okay. So when we discuss about the power flow, I'll show the driving mode also. So next is regenerative braking. Okay. So in the driving mode, so this is the direction for the battery, the power converter to the motor drive. Then it's going to act as a motor. So the regenerative braking. So during the braking mechanism also, we can use that energy to charge the batteries. That is called regenerative braking. So whenever you press the accelerator in the back rotation, so it start acting like the generator. So this energy has been sent to the power converter where it's going to charge the batteries. So there we can save the energy during the transmission. Okay. So three things it is going to take in care. One is speed, torque, and rotation direction. So this is one of the important role we can name it as. Okay. So one thing also I would like to explain. Suppose in a driving mode, if you take Tesla S, they are using induction motor. I am talking about Tesla S model. They are using an induction motor. So there, the speed of rotor is less than this constraint you already know. So I'm just giving a brief overview, like a differentiation. Suppose if it is acting like a motor, so the rotor speed is less than the rotating magnetic field of the stator. Okay. Suppose it start acting like a generator, then what's going to happen? The rotor speed obviously greater than the rotating magnetic field. Okay, these are the two things we can generally observe. Okay, so this point, just a brief overview. Some part I would like to convey to the students. So next is transmission here. So when you after converting the electrical to the mechanical, so it might be given to the transmission. Okay, what's a transmission means? Here going to have two things: single gear mechanism plus differential. Okay, so nominally if you take conventional internal combustion engines, so there we are having different gearing mechanisms. There are 4 gears, 5 gears mechanism. Most probably we have 5 gears, right? 5 gearing mechanism should be there. While coming to the electric vehicle, we are having single gear mechanism. So that's why it is very convenient for any consumer so that they can easily operate this vehicle. And this differential is definitely required so that it can taken care about during the uneven parts or irregular surfaces where they can use the differential. Okay, so due to this mechanism, it is very convenient. Okay, so while coming to here, it's a very complex one we can consider. So this the transmission is nothing but is a gearing mechanism which is going to transfer the energy of mechanical energy to the wheels. That's what it's conveying here. So this is the major concern that I would like to bring it up for you all. When you talk about the power flow consideration, first of all, we are going to get the supply from the grid. It may be single phase or 3 phase, depends on the requirement. So this supply is given to what is this called DC to AC. We can call it as on-board charger. Okay, which is going to convert the AC to the DC. So this is given to the power electronic converter. Okay. So like I already explained the block diagram. Here we are discussing the power flow. From here it is given to here. So there it's going to charge the battery. Okay. So Now, if you talk about the driving mode, so once you start the vehicle, then what's going to happen? This battery is going to discharge the energy to the DC to DC converter, where it's going to step up the voltage. That's why we can call it as high voltage bus. This is called step up the voltage. From there, it is given to the motor drive. I already explained you the motor drive is playing a very important role, which is having the power electronic components as semiconductor devices, where it's going to taking care about the frequency. We know that the speed is totally depending on the frequency. If you control the frequency, where it's going to control the speed. So it's going to convert the DC supply, which is coming from DC to DC, which is converted into AC. And this is acting as an input for the motor and generator. So here it's going to convert the electrical energy to the mechanical. So this mechanical energy is shifted to the transmission, where we are going to have single gear plus differential. So now is a differential explanation. It is some more explanation out there, which I would like to not moving on to this one. So you have to understand this single gear mechanism, which can help us to shift the energy from the motor to the wheels, which is acting as an intermediate. In conventional one, we are having different kinds of gearing mechanism. Okay, so from the battery to the DC to DC converter, from there step up, and from there it is given to the motor drive, which is an power plant devices, which is converting into, which is acting as a supply to the motor based on induction motor or the PMSM or brushed DC motors. So it's going to convert it as the transmission here. And here, one more thing you have identified in this illustration, where we are taking the supply from the high voltage bus, and here we can call it a step down voltage. We are stepping down the voltage for charging of auxiliary batteries. Okay, like I already told you that some part it may be related to the audio head unit or starting of vehicle. For starting of the vehicles also it requires or headlights, we can call it as. Okay, some accessories which is required, where we are going to supply the energy. Okay, so this is the driving mode from the battery to the wheels. So second is from the wheels to the generator, from there to the motor drive, from there to the bidirectional converter, from there to the battery for the charging. So the opposite direction we can observe. So at this condition, this motor is acting like a generator. This is called regenerative braking mechanism.
Sir,
Okay. Yes.
sir, what type of motor is used, sir?
It depends. We might be using, suppose if we take Tesla, yes, we can use induction motor. So at present trend, suppose if we take Morris Garage, there is a car, Hector, right? Morris Garage. So it might be using permanent magnet synchronous motor. Okay. And a Tata Nixon also using the PMSM. Tata Nixon is also electric vehicle, which is introduced in the recent days. There is a permanent magnet synchronous motor. So is it clear for you? Those who
Yes,
have
sir.
asked the question?
Yes, sir.
Okay. Okay, fine. So thanks for asking the good question. So fine. This is about the power flow. I believe I have given you a better idea about how the power flow is given. So is it clear to everyone? Is it fine? Do you understand what I have conveyed?
Yes, sir.
Okay, fine, fine. Thank you. So what about other one? Akhil, thank you. Good, good. I'm happy to see the response. Thank you. Simala Silva, thank you. Good. Thank you, Jyoti. Yeah, fine. So now let's move on to why the electric vehicle. Like many people have already conveyed. So let me deep dive into the major points. Not I'm talking all the points, the major points I'm considering. Suppose if you take ICE, which is combustion engines, so there we are having the tail pipes where it's going to emit the carbon dioxide into the environment, like other components are there. So that is the main reason we need to switch it over to the electric vehicle. This is the major concept that you already know. Next is many people haven't heard about W to W. This is called well to the wheel. So what does this means? Let me convey you. So when you go to the industry, you may understood in the automotive terminology. So well to the wheel. Well means, so this is the place where you're going to collect the fuel. That means called refinery, we can name. So how this refinery is reaching to the station or petrol station or diesel station? Through transmission, correct? And suppose you are having a vehicle, okay? So if you want to refill your vehicle for traveling purpose, what you have to do? You have to reach it to the station, correct? So how this reaching can be done? Through transmission, from your home to the station, to the transmission, which might be happen. And after filling it, your vehicle has been reached to the destination or other place, whatever is the place that you are moving on. This is also transmission, correct? So from the refinery, you are going to get the fuel, and this is the station where it has to reach to the fuel station. And how to fill this fuel? You have to reach the transmission. And next is after filling it, you are moving on to the destination to the transmission. Here you can observe in all the transmission, we can observe some emissions here, correct? CO2 emissions during this transmission. Emissions, we can call it as, okay? This is, we can call it as well. And this is called wheel. Well to the wheel. Well to the wheel, during this transition, how is the emission standards? That is called well to the wheel efficiency. Okay, so when you go to the industry, you may get this point. This is called well to the wheel. Okay, so during this transition, the emission standards, how it should be. Okay, so when you talk about the IC, only 20 to 30% of efficiency we can generally find because of these emissions. While coming to the electric vehicle, when you see about here to this one, suppose we can take the coal is the main fuel, through transmission reaching to the generation plant, like power plant, where we are going to generate the electricity. How it reaches to? So here there is no transmission. By the transmission lines, it might be reached. Okay, there is no emissions here. And at your home, you're going to charge the electric vehicle. So then the well to the wheel, the emission standards are well less when compared to this one, because you're charging here. No need to go to the station. So then the electric vehicle is having good efficiency of 85%. This is called well to the wheel efficiency. Okay, so this one kind of point I would like to put it in front of you. So let's talk about the convenience. So how good the convenient is this electric vehicle? So when you talk about the convenience, okay. So when you talk about the convenience, so as I already told you that it's a single gear mechanism. Okay, so because of the single gear mechanism, for every consumer who is purchasing this car, he's able to drive this vehicle without any complexity. So next is this vehicle, no need to go to the fuel station where you can charge it at your home. If it is not available, we can go to destination centers or charging stations there. And most probably, the people who are buying the electric vehicles, they plan to install the charging station at their home itself. So that is one kind of convenience we can take. So let's talk about the second point. If you look at the Tesla S model, which is an autonomous vehicle. So there, if you look at the front and the back, the boot space is very high. At the front and the back, boot space is high because all the driving, there is no mechanical parts. Okay, that means suppose if you take engine, it weighs too high. So while coming here, the mechanical parts are less because we are using only single gear. So because of the lesser mechanical components, and obviously we are distributing the batteries, we can save some space. This is called, we can call it as large storage is present. So next important constraint is, because of there is no mechanical parts inside of it, when it is moving, it's very quieter. You can see some ads for for Audi, and if you may see the ad like for the Porsche car, electric vehicle cars, you can observe in the ads. So they can highlight this part. So the car which is moving very quieter. Okay. So without any gearing mechanism inside of it because of the single, it is very quieter. Okay. So in the coming days, we might be observing the self-driving cars. So it takes other 10 more years to come. Especially in our country, it may take 10 to 15 years. So next, like someone said in the chart box itself at the beginning, the maintenance charges are less when compared to the ICE. That is the one thing. Next is the taxes that you're paying for the electric vehicle is obviously lesser. And next is when compared to the fuels. Now the fuel price is almost 96 if you are using a petrol vehicle. A diesel it might be 4 rupees lesser when compared to this, or almost 90 rupees it might be charged. So when compared to this, electricity price is less. The tariff is very less. So that is one thing. And government is encouraging for subsidy that we can discuss when you talk about the government policies. So these are the major benefits we can generally observe. Now, let me give you some understanding about what are the major challenges that the engineers is facing while they are designing the electric vehicles. So nominally, the major challenge is the charging time is very high. Even if you take advanced vehicles, even they are using the fast charging, it takes 1.5 hours to charge the vehicle. Suppose if some people couldn't able to charge afford this fast charger, they can use the regular chargers. So the charging time it may be expected to 10 hours of duration. So the charging time is very high. Where always the researchers is putting all the efforts to reduce this charging time. Even they have been introduced the fast chargers, so which is very bit expensive. So next is either you can install at your home and you can go to charging station. Suppose in our developed cities, we might be having these charging stations. When you look at in the rural areas, or if you take remote areas, we couldn't able to find the charging stations, not like the conventional one. That is the thing. And the price is high that I already explained. These are the major challenges. And one more, the long time charging, these are all related. If you see, this part, some part relates to battery management. Okay. That means depending on the battery, the charging, discharging might be happen. So this is quite related to the battery management system, which is called as BMS. I hope you understand the technical challenges. If it is,
Sir,
yes,
sir,
yeah,
sir, in that vehicle in that vehicle by keeping a dynamo, we can recharge no, sir. Meanwhile, where one battery is going to be discharged, another battery is going to be charged, such that we can improve the efficiency, right?
you want to include the dynamo.
Yes, sir. By
Okay,
keeping the dynamo, I just want to charge at the meanwhile the battery.
okay, okay. You can charge the battery, but based on the specifications of the battery, you can include the dynamo or not will be decided. Okay. So here, many people are in some assumption like, so it's only the battery which is located in the car is only for the driving of the propulsion of the vehicle and for the auxiliary components. But it's not like that. So there are many components in the car. What I explained only key components. Okay. So there are many electronic control units where they might be used for different purposes. Suppose if you take airbag system, if you take you know, BHM, body head unit, okay, our body control module is there, where it's going to taken care about the steering wheels, and where it's going to taken care about the cluster. Cluster means the speedometers, and they're going to the raindrop telltale, and all the factors are there. Okay, so there is so many issues are present. Not only these components going to drive. So based on that requirement only, we have to design the vehicle. You
Sir,
understand? Yeah.
sir, is it possible to make a vehicle that's self-recharging?
Self-rechargeable. Yes, yes. There are so many studies are happening. If you install the solar panels at the top, okay. So you understand my point?
Yes, sir.
Okay. If you install any solar panels at the top, okay. we can able to charge the vehicle. But during the transition, how well it's going to charge is a major challenge here. Okay, so whenever you at the stop, keep the vehicle at the sun, this proper sunlight and radiation is available. Okay, so that is also major concern, right? So when it's going to charge and discharge, you got my point?
Yes, sir. Thank you, sir.
Okay, fine. So I believe
Hello.
yes,
Sir,
Mr.
I
Rahman.
also have a
Yes,
question, sir.
yes, Mr. Rahman. Yeah.
Sir, can we recharge a battery while driving a car by converting the mechanical energy of the tire
Yes,
through shaft to the electrical
yes,
energy to the battery?
yes. We can do that. That is what I'm saying. There are two kinds of mechanisms are there. One is driving mode. Next is regenerative braking. Okay, so whenever you apply a brake, okay, so it start acting like start rotating the motor in the reverse direction. So where it's going to acting like a generator. Okay, so where
Yes.
the charging of the battery should be happen.
Yes, sir.
Okay, you got my point.
Okay. Okay, sir. Yes, I
Okay,
got it.
okay, thank you. Okay, thanks for the questions, Mr. Ahmad. And okay, so now let's discuss some of the key points uh, in in our country point of view. So many people are giving study on different countries. So why can't we bring up our country analysis? What's happening in our country? So I did some research on this. So we have a very urgent requirement to take it. Our climatic concerns are very serious. Okay. So the carbon emissions in our country are very high. So that we have to immediate transition to the electric vehicles is duly needed. So that's why the government is also putting so much of effort and encouraging the people to switch it over to the electric vehicles. Suppose if you start using the electric vehicles up to 2030, so there is some statistics are there. Suppose if you start using this much of percentage of electric vehicles, so it may be we can reduce 37% of CO2 emissions. So this is the graph which is representing. This is the conventional graph. This is the electric vehicle usage, where we can reduce 37%. Okay. So this statistics I have gathered from India EV story. So this is a very good article. We're going to give in every 2 months. They're going to release the article. So there I have gathered this information where you can limit this CO2 emissions. So next concern is, so we are having the power generation, but we are not utilizing up to its potential. Okay, so we have the more generation, but the consumer usage is very less. Very less means it's lesser. It's not balancing. It's not balancing. The more the generation we have, so the more the generation, the more the usage is, so that we can improve the stability of the grid. Okay, so that's why if you use the electric vehicles, the people are start charging so that they can consume the electricity where they can give the stability to the grid. Okay, so the more the generation we have, it is not using up to its potential. So if you want to balance, this is what we have to do. Okay, so this is the thing that I would like to bring it to your kind notice. So well, here I would like to tell one more point. This is called vehicle to the grid. Okay, so vehicle to the grid is in a sense means, suppose if the grid is overloaded. Okay, at this time, you can, through your electric vehicle, you can feed the energy to the grid for a small support. This is called vehicle to the grid. Presently, it is not happening. In coming days, it might be happening. So I'm recommending you to kindly Google it, this vehicle to the grid, so that you can get more information on this. Okay. So if the grid is overloaded, where you can use the electric vehicle, where you can feed the energy to the grid, so that you can improve the stability. Okay. So next is we are totally depending on other countries for running the mobility in our country. Like all the vehicles, we are totally depending on the crude oils, which is getting to different parts of our country. Maybe some Gulf or different countries, we are getting it. It's very huge scale. It's not a normal scale. Suppose if you start using the electric vehicles by 2030, according to statistics of that article, 64% of the energy we can save, the usage of 64% we can save, the fuel required for the passenger vehicles, where you can save $60 billion. Okay, if you started using the electric vehicles. So this is one kind of statistic we can say. So this is give you some understanding how better we can go to the electric vehicles. Instead of talking in general, I would like to show you the statistics so that you can believe. So this is what statistics. So 64% has been reduced if you start using electric vehicles by 2030. So what are the government policies? Many people are not aware about what are the policies of the electric vehicle in our country. So our country is the fifth largest in the automotive industry, in the manufacturing sector. Fifth largest is there. So in coming years, like 2030, they might be accepting like a third place. So that much of huge automobile industry we have. So government have introduced some NEMM scheme uh, where they are expecting to deploy the vehicles of 7 million hybrid or electric, but it is not happening yet. They have mentioned 2020. So because of so not proper management, are not aware of the schemes which is introduced by the government, are not the companies who is putting step forward to take it as a challenge. Okay, there are so many factors are affecting, but it's not happening. This is the government, this is a scheme introduced in 2013, but it's not happening. And in 2017, to encourage the companies, the manufacturers of the automobile industry, so if they have gives a solution to the low cost electric vehicle, that means the price is very high for the electric vehicle. So they are expecting the companies who is going to form a team, right, which can be called a research and development. So if they're going to do some money into that to find the low cost electric energy, so there the government has to pay 60% of amount. Okay, so this is a very good option where they're going to bear the cost. This we can call it a subsidy, which is giving an encouragement to the companies. And there is some other policies also, FAME scheme, and then the NITI Aayog also there. So always they're going to bring up the new policies for the electric vehicle. So in states, so I have done some research on this. The Karnataka is the first state who bring up the policy, which is called electric vehicle policy in 2017. And the next government is Telangana government, who has bring up a scheme in 2017, where they are expecting 100% electric vehicles by 2030, and which indirectly or directly is going to create 50,000 jobs by 2022 if they implement this kind of policy. And according to my study, recently they have updated in October 2020. They have updated the policy. I don't know how many of people are aware of this. Let me tell you for you. So in 2020, they have upgraded this policy. Suppose if you are going to purchase two-wheelers, the first 2 lakh two-wheelers, if you purchase, if anyone purchase first 2 lakh vehicles, so there is no tax. There is no tax and registration fee. There is no registration fee. So nominally it may around 3,500 rupees. It just waived off for first 2 lakh vehicles. For four-wheelers, I have seen like first 20,000 four-wheelers. If you purchase, the same situation happened for this. No tax and registration fee. Suppose if you take three-wheelers like autos and rickshaws, if you move it out to the electric, I have noticed few of the vehicles in Hyderabad are also switching over to the electric vehicles. So if you purchase 15% of retrofitting, that means any maintenance charges, it is going to bear by the government. It may cost around 15,000 of rupees per a year they're going to give for the retrofitting. So like this kind of subsidies, which is given by the Telangana government, like this, there are several schemes many people are not aware of. So if they have introduced and they are expecting 1,20,000 jobs by 2030. 1,20,000 jobs by 2030 they are expecting by introducing this policy. Okay. So, while coming to the sales, Gujarat is the top, is 4,330. And while coming to the India, 24,000 vehicles in 16-17 fiscal year. So they're expecting we double the time in 2020, but it's not happened. So the electric vehicles, if you talk in our country, if all the states switching over to the electric vehicles, directly or indirectly, they're going to create 1 crore jobs for the engineers in our country. Okay, which is stated. I am not saying like an orally. So I have given you the source. You can go and check it out. It is 1 crore jobs for electric vehicles. So what kind of designation or engineering prospects are expecting is, so battery management system. I already told you that it's a very big issue or facing by the engineers, a challenge for the engineers for the battery management system to increase the charging time, decrease the charging time. Okay, so safety engineers, powertrain engineers, telematics analysts, where they are going to take care about the automotive testing and taking care about the programming part. They are going to do the data analysis. We can name it as. Okay, so main is the battery management system engineers is very popular. We can expect the jobs in the coming years. So this is I have listed out. Mahindra Electric is the first electric car which is introduced in our country. So next, while coming to the Pune, so they have ordered 100 buses, electric buses for their public transport. In Mumbai, 6 buses for the Himachal road. Okay. So you might have already heard about Tata Nexon electric vehicle. So like someone have asked what kind of motor they might be using. So they might be using PMSM three-phase motor. Okay. So what is the capacity of the batteries? 30.2 kilowatt lithium-ion battery they are using. I already told you that because lithium-ion battery is having more density and the weight is less, so that we can expect a good efficiency. This is the capacity of battery. Okay. So in full charge, it can go up to 312 kilometers. Okay. So there are two chargers are available. Suppose if you're using a normal regular charger, it takes 8 hours to full charge. Suppose you are using a 25 kilowatt fast charger, 80% can be possible in 60 minutes, but it's a bit expensive. So, and on average, what's the price is 13.99 is on-road price. Based on the state, it may vary. This is the starting price. Tata Nexon. Next is Morris Garage, and they are also using the same motor, PMSN. Here I have not specified, but it's a PMSN motor. So the battery capacity is 45 kilowatt battery, and this is what it can drive up to 419 kilometers. It's more than this one, but the price considered also increased, double the price. Okay. Suppose if you are using the normal charger, it can take 6 to 8 hours. Suppose if you are using the fast charger, 80% can be possible in 50 minutes. Okay, this is the specification. And this is popularly used by the government industries. Suppose if you take APSPDCL or TPSPDCL, you can find this kind of car, which is Tata Tigor. Okay. So there they are using a 21 kilowatt battery where they're going to cover 213 kilometers. And if you're using a regular charger, it can take 11 hours, which is a very long time when compared to the earlier advanced vehicles. And fast charging, it may happen in 2 hours. This is a bit better. Okay, its costs around 10.5, which is around 11 lakh. The last one I would like to show is Hyundai Kona Electric. It might be coming in our country in 2021. I think the release date is not happened till now. So there are two types: short range and long range. For the short range, 39.2 kilowatt backup, so which is going to cover 300 kilometers, and it takes 6 hours of charge. Suppose if you take long range, the battery capacity has been increased. You can observe double of it, 64. It can cover 470, and full charge can be happen for 9 hours. Suppose if you're using fast charging, 54 minutes it takes. So the price is 23 lakhs. So these are the latest vehicles which is bringing it onto the Indian market. Okay, so this is what I would like to convey to you all. So this is the present scenario which is happening in our country. Okay. So many people are not aware about what are the schemes introduced by the government. So this is duly necessary for as a citizen of our country, as we are the suppose if there is any electrical engineers, they should have aware of it. So this is needed for everyone. Everyone know the operation and the mechanism, but they have to understand the schemes and present scenario in our country. Why we need to. But the bigger challenge is a global concern, like many of people have already answered that. I truly appreciate that. So that is the thing I would like to convey. So my side, I'm done with the explanation. So I'm waiting for you to ask if you have anything to discuss. You can discuss with me. So over to you, Manoj.
Yes, sir. Hello, sir.
Yes,
Can
Mr.
I
Ahmad.
question?
Yeah,
Sir, indirectly we are saying that we will decrease the use of fossil fuels. So, but indirectly we are charging it through the thermal power plant. We are producing electricity. Then also we are using coal. So
yeah.
there, yes, sir. So there we are using coal as a production of electrical energy. But then our vehicle is charging from that electrical energy. So indirectly we are using coal.
Yeah, I do understand your point,
Yes, sir.
Mr. Ahmad. But when compared to the ICE, if you look at that's why I told that point called well to the wheel.
Well to wheel.
When
Yes, sir.
compared well to the wheel, if you do the comparison, when compared to the conventional ICE, this is having good efficiency. When compared to this one is better. See, we
Okay.
can't we can limit up to some part. I am not telling about 100%. You
Okay.
got it,
Matlab,
Mr. Ahmad?
okay.
Yeah.
CO2 exhaust will be decreased as
Sir,
in
we
Yeah.
comparison.
want to know about,
Okay. Okay. Fine.
Yes.
sir,
Okay. Thank you, Mr. Yes, Suman. Yeah.
we want to know about charging infrastructure, sir.
Charging infrastructure. So in this stipulated time, I can't able to explain the charging infrastructure. For that, we can plan for a next session if possible.
Sir, if the capacity of a car is to go 312 kilometers from a
Yeah.
particular point, but if we have to reach 400 kilometers, then we need a
Okay.
charger in between, sir, in between the
Yes.
2 points. So
Yes.
for
Yes.
that
We
is
need.
so government is taking a step to install those chargers there, or sir, we have to take an initiative to take an
No,
charging
no. Government
infrastructure
is
with
already
us.
taking an initiative. Government is already paying the amount. That means
Yes,
like
sir,
an not full amount. This is like an encouragement to install, like a subsidy they are giving. Okay.
to install the
So
chargers.
install the charges. Okay.
Okay,
See, in cities it's happening, but in remote locations it's not happening. So it is slowly pacing down. So
okay.
that is a thing.
Sir, do mechanical engineers have any scope in this?
Yes, obviously the mechanical engines is obviously having this.
Sir, but you only
Yes.
said there are no mechanical parts in the EV.
No. See, mechanical engines also do study about electric motors, right?
Yeah.
Propulsions and gearing. Here we are having gearing mechanism, right? Single gear mechanism. So there is a scope. See the topics what we are discussing in the recent trends. It's not limited to one discipline. It is multidisciplinary. Anyone people can join and learn, and they can do it. Okay. So for the mechanical
Okay, sir.
people, yes, there is a very good scope.
Okay,
Sir,
sir. Thank you.
Okay.
sir,
Yes.
sir, here we are using lithium batteries. There is a possibility of a blast of batteries. How so far it is safer to the consumer?
So blasting means based on the temperature capacity inside of it. Suppose if you take Tesla S car, so I do some study on Tesla S. If you see, instead of using a very big battery, they can use 800 cells. Like a small battery should be present. So why they have kept it like this means the more exposure of air into that, so that it can dissipate the heat to the outside. Okay, so that the more safety for the batteries, like you said, like blasting or short circuiting should be taken place. Okay, so that kind of measures is before the product coming into the market. So we have to take there is a proper passage of heat dissipation to the outside. You got my point, Eddie?
Yes, sir. Yes, sir.
Okay, so before coming to the market, so many trial runs should be done by the industry. Okay, so many testers are there. How good a dissipation of heat should be to the outside. If there is no dissipation of heat to the outside, so definitely there is a scope of a sudden short circuiting and sudden blasting should be happen. Okay, okay. So I'm still
Sir,
So according to you, how much time will it take to saturate our automobile industry with the electrical vehicles?
so according to my study, it's still
Yeah,
booming up. It takes 5 to 6 years.
5 to 6 years most to saturate our industry with the electrical vehicles, sir.
Yeah,
So in
this
five
is
to
my
six years,
expectation.
okay, yes, sir. Okay, so that's what I want to. Thank you so much, sir.
Okay, this is my expectation. So let's
Yeah,
see how it goes. Suddenly, it's something will happen. Sudden
yeah.
miracles should be happening in industry. But
Because it is, yes, sir.
it is duly needed for everyone because this is an urgency. This is not a requirement. This is urgency for now.
Yes, sir, this is urgency, but I think that it will take a lot of time because to install these a lot of charges to charge us cars in between the points, 2 points where we want to go to a destination.
Yeah,
So it is very
yeah,
important. So yeah,
yeah. So people
okay.
need much more awareness.
Yes, sir.
So many people think that electric vehicle. Okay, so this is very expensive and there is no charging points are available. So slowly it has to give some initiation.
So people also say that these cars do not have that much of power which the our traditional
So
cars have.
based on the commute we can purchase.
Yes,
Basically, suppose if you take me, I won't travel for 500 to 600 kilometers. Hardly I can travel up to the 150 or 200 kilometers. So based
yes,
on the consumer's requirement only we can purchase.
yes, sir.
Okay. So based on your constraint only we have to purchase. So that is what I can convey.
For current scenario, sir.
Yeah, yeah. For current scenario, we have to do the analyzation. Don't depend on others. Why can't we take the initiation from our like that?
Yes, sir. Thank you so much.
Thank you, Mr. Ahmad.
sir, is there any warranty for this vehicle, sir? Where the batteries are going to be changed?
Yeah, yeah. There should be proper retrofitting by the utility company. Like suppose if you take Tata, Nexa, or something, they have having proper warranty. They're going to taking care about the charging, discharging. Like continuous service maintenance should be there. Short warranty also there.
Sir, the performance is also going to be reduced going on years.
Yeah, it depends. It depends on the usage. Obviously, the depreciation should be there. It's not the same value that we can expect in a yearly basis. But when compared to the combustion engines, the electric vehicles maintenance is very less, and the efficiency also quite good. Okay. Any other questions from the participants?
Sir, the initial cost is very high, sir, for these vehicles.
Yes, that is the only. But when you compensate with the maintenance charges in the long run, the same will be compensated. Okay. In the long run, we have to see the statistics. That's why I have shown you the statistics. In the long run, this is the better option. Let's see. There are so much of research is happening, like battery management system, where we can limit the charging time. Okay. So if you limit the charging time, if you reduce the price of the batteries, obviously the cost of the vehicle also gradually reduces. Let's hope for the best. So Akash, what will happen if the battery is fully discharged? So nominally, while you're driving to the vehicle, it's going to show some in the cluster itself. It's going to mention about how much of charging or discharging is happening. So based on that, we have to estimate. Okay. So before starting from a particular location, on the way to the destination, just make sure yourself there should be a proper facility for the charging your vehicle. So sometimes portable charges is available for the vehicle. If you take the Hector, like a Morris carriage vehicle, there is a portable charges are there where you can carry in the vehicle. So at your particular location, which is have the better facility, where you can put it to the power point, and there you can charge your vehicle. I hope I have answered your question, Akash.
Sir,
Regenerative braking, yeah.
sir, in case of accidents, is there any chance of having more explosion than the petrol engines?
Uh, yeah, there is some cases are there because we are using some lithium-ion batteries. So there are cases are there. Okay. But like I already told you that before coming to the market, there are so many testing should be there. It might be, you know, the safety concerns which is given by that. So most of the safety should be there. But still, there might be chances might happen for like an explosion or something. But before coming to the market, make sure that the utility company or the manufacturers will taking care about those issues. So Prasad, regenerative braking scope in electric vehicle. Uh, Regenerative braking scope in electric vehicles. Yeah, it's already there in the electric vehicles itself. Scope in a sense, you want to pursue the career in regenerative braking or what? So please convey the question clearly. So okay, by using dynamo to charge the battery in the running time. Yeah, we can use the dynamo also, but based on the battery specification that you're using, based on the motor that you're using. Suppose if you're using a induction motor, you might be using other type of PMSM motors. So if you're installing the dynamo, is it feasible for it? But the dynamo is not preferable. It some part relates to the weight of the vehicle also. Okay, so based on the configuration of the vehicle, they can support for this kind of installation. Okay, so that is what I can convey. But instead of installing a new component to that, why can't you use the single machine where it can do the bidirectional operation? So here we can relate to the cost benefit of the organization. So if you talk organization point of view, they can think like the cost benefit point of view. Instead of using another extra component, it's an extra burden for the consumer also, where it's going to increase the price of the vehicle. Why can't you use the single motor, which can be acting as both generator and the motor? I think I have answered your question again. Thank you, Prasad.
Sir, electric vehicles are waterproof, sir. Is
Waterproof. It depends on specification. ID. These are not major concerns like waterproof or something, but better insulation is placed for the batteries. That I can assure you. Better insulation should be there for the batteries. The remaining part is based on the vehicle that we are purchasing. And I don't believe that it's not a major concern for the vehicle. Okay, thank you. Okay.
Hello, sir.
Uh, yes, Akash. Yeah.
Sir, if the one battery is damaged, then
Okay.
the whole circuit will damage.
No.
How it's work?
It's not like that. We are going to separate the batteries in a proper way. And suppose if any that means any short circuit is happening for the battery, we are going to design in such a way that it can restrict up to that part only. It isn't has to distribute to the other part of the batteries. So we are going to design in such a way that it can isolate from that point, not disturbing other batteries. In that way, we can do the configuration. In that way, we have to do the connections. You got the point, Akash?
Yes, sir. Thank you.
Okay. Okay. Thank you.
sir, how much the government is going to give subsidy, sir?
Uh, that is what I'm saying. Suppose if you take the Telangana government, like I told you, if you want to purchase a four-wheeler, so they're going to waive off the tax and the registration fee of the vehicle. Suppose it costs around, I did some calculation. It's between 3,000 to 4,000. So 3,000 to 4,000 amount should be waived off. Okay, suppose if your vehicle cost is 1 lakh means, so 5,000, 4 to 5,000 has been waived off. 95,000 you have to pay to the manufacturer. So that is one kind of scheme. Like this, there are several schemes on there, so that you can check it out. So according to my analysis for Telangana, I have noticed, and other states also are putting step forward to convert into electric vehicles. For two-wheelers, also the same situation. Okay. Any other questions, please? Before closing, I would like to tell you. We the NFA Technologies are well proficient to deliver the technical webinars. If you want to organize for your institution or organization, or if you want to organize any internship, industrial internship, and faculty development programs or customized trainings, you can reach out to us. This is our contact details. I'm recommending you through to kindly note down these details, and you can follow us in our Facebook page, Senfair India. So kindly go through this page and hit a like so that we are going to keep you updated regarding the upcoming trainings. We have a very big plan in the next coming month. We would like to organize internships in association with NSIC, as it is a government of India enterprise. So there we are going to organize the internships like IoT, and for the mechanical people, we are going to organize the cryo, CATIA. So you can go through. Why can't you go and visit our website? So what are the trainings we are offering, and how good the feedback we have from the participants. So I'll update you through the ambassadors, so they may pass it on to you, or I kindly recommending you. So kindly go through the website. Okay. So
Hello.
NSIC is a government of India enterprise where you're going to get the certificate directly from the NSIC. Okay. So let me show you the NSIC. So this is a trusted client for us. So this is the NSIC. So we are going to organize almost 5 to 6 internships where it's going to be mandatory for all the engineering graduates in different institutions with the affordable price. As it is a government of India enterprise, they are going to choose like affordable price, like a quality training. So we are having the industrial experts where they're going to deliver the training. So I'm recommending you to kindly register for these trainings also. So in order to keep you updated, so kindly go through our website and kindly go to the Facebook page. So where you can type it as Enflare India. Okay. Okay, fine. Manoj, I believe there is no questions from the participants for now.
Hello.
Yes, Ahmad. Yeah. Yes, Ahmad. Tell me. Hello.
Sir. Hello.
Yes,
Hello.
Ahmad.
Hello.
Ahmad, I can hear you. Yes, tell me.
Yes, sir. So technologically, electrical vehicles are not accepted. But what do you think the socially accept this electrical vehicle? It will be an easy task or it will be a hard task for us?
Uh, I believe it's a hard task for us because
Okay. Yes,
we
sir.
need to create the awareness to the people, right? So
Exactly, sir.
if you want to make the people to believe you what you're saying,
Yes,
so
sir.
we have to put all the statistics in front of them,
Yeah, all
all
the
the statistics,
benefits.
all the benefits, statistics. So if you tell like a orally, nobody can believe you.
Yeah.
We have to get some reports. This is what according to study shows that, according to research shows that, if
Yeah.
you're going to use this, going to benefits you're going to get.
Because what do I think that all the disadvantages we are facing in the electrical vehicles, that is in
Yeah,
the internal combustion engines also.
yeah.
And I,
Yeah,
so
anyway,
yes, sir.
anything there might be some advantages, disadvantages of that. So there is
Yes,
no
sir.
other product in our world. There is an fully advantages.
Yes, sir. We have that limited petrol or diesel tank over there also, just like a battery here.
Yeah,
So the socially to accept this electrical vehicles as our own personal car or anything, so it
mm,
is something a difficult task for us to accept it.
yeah, yes.
So
It
therefore,
takes
it
time.
will take a lot of time. I think, sir.
Yeah,
Yes, sir. Okay. Thank you, sir.
let's hope for the
Yes, sir.
best of one.
Yes, obviously, hope for the best.
Yeah. So may I know
Thank you, sir.
where are you from? You're from?
Sir, I am from Jhansi.
You're from which institution? You're a
I
faculty or
am from
something?
Sir Rajki Engineering College. It is in Mainpuri. It is AKTU affiliated government college. AKTU,
Uh,
it is a UP government college.
okay,
So I belong from there. I'm a third year electrical engineering student.
okay. That's great. Ahmad.
Yes, sir.
Thanks. Nice interaction with you.
Okay, thank you so much, sir.
Thank
Same
you.
here, sir.
Thank you. So, Ahmad, I would like to tell you one more thing. We are planning for
Yes, sir.
internship from this organization, Enflare Technologies.
Okay.
So, kindly follow our page, Enflare India. So, just look at it, and when we are going to update, please mobilize
Okay,
50 friends.
definitely, sir. Definitely, I'm going to follow it.
Sure, sure. Thank you, Amma. Thank
Okay.
you.
Thank you, sir.
Yeah, Manoj. Yeah.
Yeah, okay. Now I request participants to switch on your camera to have a snap with the speaker. Sir, you can stop presenting, sir.
Okay.
Now I request participants to switch on your camera to have a snap with the speaker.
Is it necessary, Manoj?
Sir, it's not mandatory, sir.
If it is necessary, means okay.
Uh,
Okay. Let's have no issues. I think I need to join back in a second, Manoj. Shall I join back? I think my camera is having some issue.
sir, no worries, sir.
Okay. So I'll join back in a second. I request the participant, please stay back. I'll join back in a second.
Okay, sir.
Meanwhile, please give your valuable feedback uh, when you can share your
Sir,
valuable
I
feedback right
request participants to give your valuable feedback in the link provided, and e-certificate will be provided for the participants who have submitted their feedback.
So, do we have to leave this session or we have to wait?
Uh, Guys, just wait a minute. Sir will join in a second, and
Okay, 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 no problem.
we'll have vote of thanks to the sir, and we can leave.
Okay.
My camera is not working.
Yeah, no worries, sir. Yeah. Thank you, sir, for your wonderful session. Most of the students got to know many things about the electrical vehicles in detail. And by this, I would like to wrap up the session. I thank each and every participant for your gracious presence in this event. It means a lot to us. Thank you.
Thank you, sir. Thank you very much for your encouragement, and you have given more details on the hybrid electric vehicle. Thank you.
Thank you, Nagras. Thanks for inviting me. I'm looking forward to associate with Vaagdevi College of Engineering in the coming days.
Yes, sir. Within a 1 week, we will communicate you regarding the MOUs and all those things. Our
Sure,
students
sir.
are willing to do the interns.
Sure.
That's why we have communicated about this, sir.
Okay. Sure, sir.
Even
Definitely.
even
Yeah.
our HOD have joined this meeting, and due to his
Yeah.
busy schedule, he left that. But
Okay.
sir is given a word. We have a MOU with you.
Okay. Thank you, sir. Thank you very much.
Okay, sir.
I'm
Thank you.
looking
Thank
forward,
you
sir.
very much.
Thank you, sir.
Thank you.
Yeah. I also want to thank Nagaraju sir for coordinating us, and also want to thank Balraju sir being here with us. Thank you, sir.
Thank you. Thank you.
So, Nagaraj sir, please convey my best wishes to head of the department and the management of Vaagdevi College of Engineering. And I thank everyone who have made this session as more interactive as possible. So, without your interaction, it shouldn't be that much of interesting. So, thanks for your questions, and thank you everyone. I believe I can see you back again for another outstanding and wonderful session in the coming days.
Sure,
So,
sir. Thank you,
Venkatesa,
sir.
Yeah.
hello?
Yes, Ahmad. Yeah.
Venkatesa, you have given the number, that is your contact number or someone's contact number in the PPT as you have shown.
That is the company's number. I can share mine also if you want. You can take it.
So, from where
Manoj,
will I get your
uh,
number, sir?
so
Sir,
you can look it in chat box. Manoj, can I share the contact number in chat box with your kind permission?
Yeah, sure, sir.
Ahmad,
Okay.
it is for you.
Okay. Thank you, sir. Thank you.
Okay. Okay, fine, Manoj. I would like to appreciate Mr. Manoj and who have coordinated with me, Sai Ram and Akash, who have
Yes, sir,
coordinated and sent
Sairam.
me the proper mails and coordinated well. I truly appreciate your organization as organizing this kind of events and your active participation and taking it as a responsibility. It was starting with to end. You have done a great job. Thank you.
Thank you, sir. Guys, you can leave the meet. Thank you.